Coming up on This Week in Radio Tech, Cam Lasley is our guest. You haven't heard of Cam Lasley? Well, I hadn't either until I started following him on Facebook about broadcast engineering topics and IP radio, including Wi-Fi topics. He's got information coming up in just a few minutes of the things that we as engineers need to know about handling IP radios and Wi-Fi. It's really interesting. Get ready for a data dump here coming up next on TWiRT.
This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support online at bgs.cc. By Broadcast Bionics with the Bionic Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Air, featuring Playout One radio automation software, comprehensive streaming solutions, website content management, and social media tools for maximum listener engagement on the web at AIIR.com. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts.
Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb at the top of the tower. Hello there, I'm Kirk Harnack. I'm so glad that you've joined us. We're going to have a good show today, an interesting show, talk about some technologies that are allied to radio engineering technology, and learn a few things that go along with what we need to know for today's IT world, including wireless communications using IT packets. So I'm in Nashville, Tennessee. I'm in the Telos Alliance studio. You know that because the logo's right back. Oh, it's on my shirt too. Oh, goodness gracious. It's on even on my cup. Yeah. Yes, I've been bought by Telos Alliance. They own me. At least they give me a couple hours off every Thursday to do this show. So I appreciate that. It is a kind of a cloudy, rainy day here in Nashville, but it's otherwise not too bad. That's the weather report from Nashville. Chris Tarr is not with us today. He is on the road. We were hoping he could check in. Maybe he still will sometime during the hour. But I'm going to get on Interstate 65 just in Nashville here and drive north for about 2 hours and 10 minutes or so. And we're going to check in with my good new friend, Cam Lasley. Cam, welcome in. It's good to see you, sir.
Hey, thanks for having me on.
It's good to have you on, Cam. And you and I became friends on Facebook. We had not run into each other in the real world, so we're Facebook friends. And you've posted first of all, tell us what you do there in around Upton, Kentucky. You're close to Elizabethtown, E-Town, Kentucky, right?
Yes, yeah, we're just south of Elizabethtown. So I own a company called Telecast Communications. We are a rural internet service provider that uses wireless technology to provide broadband service to some of these far out rural areas that really don't have any other options for internet service. So especially in areas that have really outdated DSL infrastructure or that might not even have that solely rely on satellite communications for their internet or communication needs, we are able to provide them a high-speed, reliable, and affordable internet service that just uses wireless technology that we install on water towers, communications towers, silos, anything that gives us vertical elevation. And it's a really effective way and a cost-effective way to get internet service to some of these communities that need it the most.
Indeed. We've had other guests on the show talk a little bit about wireless ISP services, and I've talked about it a bit too. In the state of Mississippi, our radio stations in Mississippi, Delta Radio Inc. or LLC, we actually have a wireless WISP, wireless ISP services to a couple of our transmitter sites and to one of our studio sites, and that has been very valuable to us, and the trade advertising has been valuable to that wireless ISP. And I realize there are all different levels of wireless ISPs in terms of their, you might say, professionalism, quality of installations, quality of infrastructure in terms of their backbone, their distribution network. If you would kind of tell me where you guys fit into that. I'm sure you think, hey, no, we're doing great, but tell me technology-wise and the quality, kind of where you guys fit in the picture.
Sure. So primarily what we utilize is unlicensed 5 gigahertz for our last mile delivery. So there's not a
Last
whole
mile,
lot that we've
okay.
done licensed yet. So
Mhm.
really when it comes to the wireless internet service provider kind of thing or genre of wireless, there's really a couple of different bands that are most commonly used, especially by us smaller guys. So some of your really, really rural far out ISPs might still be using 2.4 gigahertz networks to be able to punch through some foliage or whatnot. Granted, we only have a couple of customers that we use the 2.4 band on because it's the most susceptible to noise and we find that's just not reliable. So we only offer that as an absolute last ditch service for somebody who just says, hey, I just need the bare minimum to get connected to the internet. What we use the most of is unlicensed 5 gigahertz. So we've got a pretty good chunk of the lower, mid, and upper 5 gigahertz bands that we can utilize for our wireless service. So we've probably got about 65 to 70% of our network utilizing 5 gigahertz spectrum. Stepping up from there, we use a couple of 11 gigahertz links for our high capacity links or to sites that require, a really high uptime or really high stability. Not saying that 5 gigahertz isn't reliable, but 11 gigahertz does give us some FCC protection from interference and a couple other benefits as well. The other one that most WISPs utilize now is the 60 gigahertz band. Now, this one is the most picky of all the bands because when you're talking about such a small wavelength, your precision, your alignment has to be so precise. It's crazy. Like, a
Hmm.
quarter turn of a little adjustment screw can completely throw the link out of alignment. So it's great to use in short distance connections. And we offer up to a gigabit service on that now. So in some of these rural areas that have a high capacity backhaul or even fiber fed directly to the tower, we can still offer gigabit service with a pretty reliable uptime in these far out areas that previously only had DSL service or satellite available to them. So that's just a couple of the
That's
most common
yeah.
things that we have in the WISP industry there.
This is a great introduction. I've got questions, and I know you're going to be able to answer them. They're not hard for somebody skilled in this, and so that's what I want to find out from you. Hey, it's already time. We have a commercial break we take early in the show, and it's this one. I'm Kirk Harnack along with Cam Lasley, and he'll tell you about his company and what they do as we go through. But more importantly, we're going to talk about the services and how these things work technologically and how broadcast engineers can benefit from having a good relationship with a wireless ISP, because there certainly are a lot of them all across the country. I'm Kirk Harnack. Our show is brought to you in part by our friends at Air, A-I-I-R, air.com. And here's my buddy, Ricky Lee. Hey, it's Kirk Harnack, and I'm here with Ricky Lee, the CEO of Air. Ricky, you guys make a fantastic automation system, but streaming is a really big deal. Tell me about streaming with Air.
It really is. We've got a beautiful streaming platform with an incredible dashboard with fantastic analytics. And you can buy it for just $20 a month. All you can eat. No limits on bandwidth or bit rates. And you can also record shows as well. So if you like to deliver on-demand content for $20 a month, you can stream and deliver that on-demand content to an RSS feed that can feed your radio player, your mobile apps, or a podcast that people can download and enjoy.
Now, $20 a month, that must be for just some slow MP3, right?
No, MP3, AAC, and we also now support HLS, which is big in the industry right now.
Wow, that's pretty amazing. How do I start to explore or find out more about streaming through Air?
You go to air.com, AIIR.com/streaming. And from there, with a credit card, you can sign up and get started.
All right, working out technical problems here. Thanks so much for sponsoring this week in Radio Tech. Thanks a lot to Lifesaver with happens to go by the name of Suncast, who saves me from myself on so many shows. All right, I was just texting actually back and forth with our guest Cam Lasley during the commercial break. And Cam, I'm sorry I didn't make it clear. I need to put this in every email to my guests. We live on Facebook in several places, and then what Suncast, our producer, does is he takes every live show and he edits the front off of it where we're just prattling on about things coming up in the show. And he also fixes any little technical glitches that are fixable. My computer's problem that I'm having right now is not really fixable, but he does the best he can, the best that can be done to fix the show. And then we republish the show typically on Fridays, and then put that out on Facebook and on other social media, on X and on LinkedIn. We let people know that the show is there. So if you follow me or follow This Week in Radio Tech, we're there. Yes, friends, I'm aware that it looks like my bit rate is terrible, and this is my computer just behaving very badly. Its CPU is almost fully saturated. Doing what? I don't know, because it wasn't doing this 5 minutes ago. And I've done nothing different. I've literally touched nothing on the computer, and it just goes up and down, up and down. So, sorry. By the next show, I may use a lesser computer that hasn't been updated. All right, Cam Lasley is our guest, and Cam, you explained briefly about what you use different segments of bandwidth for: the 2.4 gigahertz band, 5.8, both unlicensed, 11 gigahertz. That'll be licensed, and the 60 gigahertz band. Is 60 gigahertz typically licensed or unlicensed, Cam?
60 gigahertz is unlicensed. So that's one of the great things about 60 gigahertz. And here in the past couple of years, we have seen a great number of wireless providers start migrating to 60 gigahertz just because it offers significantly faster speeds. But also you can turn around and still feed other equipment with that as well. So being able to have a ton of extra overhead on your link, let's say, even if you had a 500 by 500 megabit backhaul or whatnot, you can still use that high capacity link to make sure that you're never going to hit a bottleneck on that link. So yes, 60 gigahertz is unlicensed. It follows under the same rules as 2.4 and 5 gigahertz for use. So 60 gigahertz, like I said, 60 gigahertz has come a long way in the past couple of years with WISPs to start competing with some of these cable and fiber telcos that may have a monopoly in these other areas, where even in city areas, we've started connecting a lot more customers in our city limits this past year than we ever have before. I think, if I remember the statistics correctly, 23% of our new customers last year lived within our city limits here in Hodgenville, where they've got Windstream Fiber. There's another local fiber co-op that's great to work with, and Comcast. So this has allowed us to start competing with some of these national carriers that are supposed to be the biggest and the best. And a lot of times people like to go with us because we're local. We support our local athletics. We support other local businesses. People like having somebody local to work with. They don't always like working with the mega corporations, just on the topic of customer service, customer care, things like that. Talking about the 5 gigahertz band, the 5 gigahertz band is kind of a universal frequency that a lot of people use for point-to-point links. It offers great reliability. It is decently fast. So depending on the type of radios you use, you can go anywhere from 300 to 800 megs up or down, just depending on your configuration. And it's the easiest. There's the most amount of products out there that work in the 5 gigahertz band. So companies like Ubiquiti, sure, they've got some 2.4 stuff, but they're not really evolving the 2.4 band anymore just because it's an older technology. There's not a whole lot of people that still use it out there because it has a lot of speed and noise limitations. And it's just overall not as reliable of a connection as, 511 or 60 gigahertz. So we use 5 gigahertz on a lot of our backhauls for customers or for tower sites that have upwards of, 25 to 50 customers. Typically we use something like an air fiber, which will give us anywhere between 300 to 500 megs down on a clean channel. And, we can go to smaller channels if we need to, but anything that we need more than 300 to 500 meg on a tower, we typically go 11 gig licensed because you can take it a whole lot further and with higher speed, and it's FCC protected to make sure that you don't have any interference on that link. Or if it's a shorter link and we need more capacity to a tower, we can always resort to the 60 gigahertz point-to-point gear, which can deliver symmetrical gigabit speeds and more. Some of the new products like the Ubiquiti Wave Pros, we actually just bought a couple to upgrade a tower site. They can actually do 2.5 gigabit symmetrical on those. So that gives you a bunch of overhead, especially if you're offering gigabit last mile services to your customer from your tower. So it's great technology, and it has so many different uses, and the wireless internet provider industry is just one of them.
Wow. Okay. Well, lots of great information, Cam. So let me ask about one of the aspects of setting up wireless IP radios, and this has always been of interest to me. I've got my own theories on it, but maybe you know for sure. You know, these wireless radios have a lot of automatic functions. Some can do automatic frequency moving around, especially in the unlicensed areas. If you're on a licensed channel, well, then you're on that channel. But I understand there's certainly a trade-off between the bandwidth that the radios are set up for and the throughput, the channel capacity that's going on there. But it's also been my impression, correct me if I'm wrong, that if you're using a lot of bandwidth in terms of megahertz of bandwidth, your signal may be less robust. I've had some shots that were a little iffy. If I narrowed up the bandwidth to just a 10 megahertz channel, something like that, I tended to get much more reliable operation than a 40 megahertz or so channel. So talk to us about that trade-off between the bandwidth you set the radios for and reliability. And then as a wireless ISP, do you tend to engineer that, or do you tend to just use the defaults or let it go as high as it'll possibly go?
Sure. So typically, when we set up a point-to-point link, we look at what's going to be needed at the other end. So typically on 5 gigahertz with AirMax gear, which is just the regular Wi-Fi 5-based radios that Ubiquiti makes, typically we never go higher than 40 megahertz on those, and that'll give us around 250 meg symmetrical on those if we're using flexible timing usually. So usually that accommodates a tower site between 25 and probably 25 to 35 people can get by just fine with having that tower on 200 to 250 megs of capacity if it's stable and reliable. So really we just look at overall, what is the distance of the link, what are the path requirements, and is there a lot of noise in this area? Are we shooting over a city area? Are we shooting over a rural area that we don't have to worry about that? So here's technically my rule of thumb. I'm a big fan of RF elements. They make several different types of horn antennas for 5 and 6 gigahertz now, wideband, and they also make lots of point-to-point dishes as well. So we use their asymmetrical and symmetrical horns for last mile delivery, but we use their ultra dishes, which is what they call it, for our point-to-point links. So typically any link that is 2.5 miles or less, we can get away with a 12-inch dish most of the time. Anything that is over 2.5 miles automatically gets a 2-foot dish from a reliability standpoint. The benefit of that is if we run a slightly larger dish, we can kind of back the power down on the radios to make sure that our modulation rates are staying high. So it's kind of the same thing in the broadcast world. Let's take an FM radio station, for example. You can have a translator that's pushing, 300 or 500 watts up to, a single bay antenna and, get, whatever 250, 300 watts ERP out of it. Or you can run less power and use a bigger antenna with more gain on it to where you don't have to push so much power out of the transmitter. It's the same thing in the WISP industry. So, like I said, typically we just look at what are the requirements of the link, and then we kind of over-engineer it a little bit just to err on the side of caution and give ourselves some headroom. But yeah, anything greater than about a 2.5 mile link, we just go ahead and put a 2-foot dish on it to make sure that our signal to noise ratio is excellent. Typically, we strive for a minimum of 28 dB of difference between our signal level and the noise floor. That's kind of the rule of thumb there. But yeah.
Gotcha. Interesting. Okay. When you think about the modulation scheme, and you mentioned that in relation to whether the IP radio is trying to put out all the power that it can, or if some of the gain of the link is being made up by less power but a larger dish with more gain to it. Thinking about the modulation schemes that are available, and by the way, there's a great Wikipedia entry about how this stuff works and to help you understand. There's also good videos on YouTube, but there are different modulation schemes, and this is where you get into mentioned that BPSK, QPSK, 16 QAM, 64 QAM, 256 QAM, et cetera, up to 1024 QAM and maybe higher. I don't know if it goes any higher. But tell me about modulation scheme and what you guys do. How do you choose the right modulation scheme, or do you just always let it fly up to the highest that it will automatically do?
Sure. So when you're talking about spectral efficiency, typically you strive for the highest modulation rates possible. So the higher the modulation rate, the more throughput you can get in a specified bandwidth. So for example, all of our point-to-point links on AirMax, we want full modulation, because full modulation means that we are getting the most capacity out of that link as possible. We're being as efficient with the spectrum and the bandwidth that we're taking up as possible. So on the AirMax equipment, it's a Wi-Fi 5 based radio, which goes up to 256 QAM. So typically on any sort of point-to-point or even last mile services, we strive for the highest modulation rate possible, just to be as efficient and get the most amount of speed and traffic out of that bandwidth that we've got set on the radio, which typically for all of our last mile services, we use 40 megahertz in the 5 gigahertz band. So at 256 QAM, that usually gives us a typical PHY rate. Actually, I'm not sure on the PHY rates of the Wi-Fi 5 stuff, but that gives us a real-world throughput of around 250 to 280 megabit per second download speeds in a clean 40 megahertz channel that has full 8x or 256 QAM modulation. Now, with the air fiber stuff, the solely point-to-point gear, it's a Wi-Fi 6 based radio with the AX standard. So it goes up to 1024 QAM. So that's 10x modulation. So whenever we have a point-to-point link, when we're using those higher modulation radios, we always want to make sure that under 99% of circumstances, we want full 10x modulation to get as much out of that point-to-point link as possible. So modulation in the WISP world is a little bit different than modulation in the broadcast world, where you can, with this, let's say FM, for example, you've got your 75 kilohertz of deviation in your FM channels. If you're over modulating, you're going outside of that 75 kilohertz deviation and bleeding over into other bands. In the WISP world, we don't really have that, because we set strict channel widths, and since it's a digital signal, typically it doesn't have the same troubles as analog modulation, so they're a little bit different there. But still, when it comes to the WISP world, we want to make sure that we are connecting at the highest modulation rate that the radio will support, which under most circumstances is 8x and 10x, just to where we're being as efficient with the amount of spectrum that we're taking up, because there's only so much spectrum that we can utilize before we run out and start interfering with other devices on the tower. And there's such things as GPS co-location. That's a whole separate topic. But so typically in the WISP world, we strive for the highest modulation rate possible to get the most speed and efficiency out of those links to our towers and to our end customers as well.
Wow. All right. I've got a couple of questions coming up after this commercial break. You are really making this clear, Cam. I am so glad that I met you and that we have you on the show here to explain these technical things about IP radio links. Coming up after the break, Cam, the two questions I'm going to have for you out of the gate are going to be, if your IP radio, typically it's got a web interface and you can see what it's doing, it'll tell you. If your IP radio is not doing as much, you said, 4x, 5x, 8x. If your radio is not doing as much, as big a QAM as it could. In other words, if it says, hey, I don't have enough signal to do 8x, so I'm going to do 4x. What are some of the first things you would do to engineer that better so your radios had plenty of signal to do the modulation that they're capable of? So that'll be question number one. And question number two is kind of like the gym membership question. And this is, how much, bandwidth does a WISP need, or any ISP need, coming into your facility from your carrier, your supplier, in order to properly have enough bandwidth for your customers to where they're not complaining, because they're not always going to get the speed they think they're paying for, or maybe there's a way that you arrange it to where they either can, or their expectations are held in line. So I want to see how that works. How much do you have to buy? Because you're going to be selling in aggregate more than you're buying. So I want to understand how that works. All right. It's This Week in Radio Tech. I'm Kirk Harnack. Questions and answers coming up from Cam Lasley. He is the owner of a company. Cam, I'm sorry, I don't have my note in front of me right now because my computer is hobbling. The name of your company is
Telecast Communications.
I thought it was Telecast, but I wanted to be sure. Okay, Telecast Communications in Upton, Kentucky, just outside of Elizabethtown, Kentucky. So we appreciate Cam. All right. Hey, our show's brought to you in part by our friends at Broadcast Bionics. And Broadcast Bionics, a couple of years ago, invented this really cool way to deploy containerized software systems. These are typically broadcast functions. My employer, Telos Alliance, makes some really cool things that run in containers. And these also run in the Broadcast Bionics virtual rack. Let's see if we can get a picture of virtual rack on the screen for us. Virtual rack, you can have, if you want, you can have your entire air chain in one place and backed up as well on another server, or you can just do portions of your air chain in that server. And not just Telos Alliance containers are available. They're also available from 2WCOM, Sound4, and Ferncast now has joined the club of providing broadcast infrastructure running in a virtualized server environment. Now, the virtual rack from Broadcast Bionics, this makes it easy. You're not having to pay anybody to come and set up your containerized software for you, and you're getting a lot of efficiency because you can run a number of, even quite a few, different pieces of infrastructure, different functions in a server. In fact, Broadcast Bionics sells this in 2 different sizes, and they even tell you how many processing units you've got to deal with and how much each new thing will take. It's kind of like a vending machine, if you will, a candy store. You go into the GUI, the web interface of the virtual rack, and you pick the things that you want to run in that virtual rack. Whether you want to run, 1 or 2 or 3 or 4 audio consoles, you can do that. You can select to run some audio processing. You can do that. You need audio codecs to get your audio in and out across the public internet or private leased lines. You can do that as well. And even put a phone system in, like the Telos VX. You can put that phone system in your virtual rack. They thought of everything here at Broadcast Bionics, including having a backup of all your settings, so you can easily back that up. And you can also have automatic failover. So you can fail over to another virtual rack system almost instantly. It's really cool the way this works. And these are so easy to install. You pick the function that you want, you click a button, you install it, you give it some IP addresses and a few other basic pieces of information. And then now, of course, the software coming from each manufacturer, that's licensed separately by the manufacturer. So if you want your Sound4 processing or codecs to run, or your Telos phone system, or your Telos audio console to run, you would license that separately through a dealer for those. Broadcast Bionics is a dealer for these companies as well. So you can do one-stop shopping too. But this is how it works. It's so cool. You can get a great demo on their website at Broadcast Bionics. It's bionics.co.uk. And there are some videos at the bottom of that screen. You can see those and get your, see how it works. I've been super impressed. And I got to tell you, over at Telos Alliance, our own development engineers have been really impressed with what Broadcast Bionics is doing. Thanks so much, Broadcast Bionics, for sponsoring This Week in Radio Tech. I'm using some containerized software myself at some of my stations, and it's been great. 2 years running now, and we use phone systems and audio consoles. All right, this week in Radio Tech, I'm Kirk Harnack, and our guest is Cam Lasley. And Cam, I've got IP radios that sometimes want to bounce around between different modulation schemes, and the 4x, 6x, 8x things I talked about earlier. What do I need to look out for? Is that okay, or should I be concerned I need to make some improvements somewhere?
So typically, when you're planning a point-to-point link, you want to have the best modulation and capacity as possible. So, for if you are having issues with your point-to-point link, like let's say you got modulation rates that are bouncing all over the place, you're having capacity issues, or even packet loss, these can all be present when a link is not performing the way that it needs to. So the first thing that I check is signal level, and that corresponds with alignment of the dish as well to an extent. Number one, we want to make sure that the dishes are aligned properly, especially if you have a parabolic antenna. You need to make sure that your horizontal and vertical alignment is spot on between the two locations to make sure that your horizontal and vertical data chains are balanced, but you also want to make sure that you've got the best signal level possible. And that also corresponds with signal to noise ratio, which is kind of my next topic here about interference. So if you've got a good signal level, typically, -50, -55 is what I consider decent for a point-to-point link. You first want to check to make sure that you're operating on a clean channel, especially if you're using unlicensed frequencies. If you're not on a clean channel, that can cause capacity issues, packet loss, and some other weird things to happen on that link. So one of the cool things I like about Ubiquiti is they have this thing called AirMagic, and 99% of the time it works exactly as it should. A lot of the new Ubiquiti radios will actually sit there and do channel scans in the background to analyze the environment around it to determine where the clean channels are. And it'll show you what channels have the lowest noise on them, and it will recommend going to those channels. It's really cool if you've never seen it before. So if your signal level is good and you're operating in a clean channel, that's going to take care of 99% of link issues. The last thing I want to touch base on is clear line of sight in Fresno zones. So we have a couple of locations where it's not 100% clear line of sight. Like we've got one link, a little short link between two tower sites where it's clipping to the top, it's like clipping the very top of some pine trees. And that link, every once in a while, we'll see it kind of fluctuates its modulation rates between 6x and 8x, or sorry, 6x and 4x. Now, granted, it's not a huge deal on that link because it's only a relay that serves a couple of customers, and we don't have any issues out of it just because it's not pushing a lot of traffic. But whenever you're doing point-to-point links, especially anything above 2.4 gigahertz, so that includes 5, 11, 24, and 60 gigahertz, you want to make sure that you've got a clear line of sight at the bare minimum. Now, the second part of that is something called your Fresnel zone. With parabolic dishes, you can see the two sites eye to eye. But if you've got obstacles that are around that, then that can also cause some issues as well, because parabolic dishes and with those point-to-points, they need a little bit of breathing room on that point-to-point wireless link. So I'm trying to think of a good analogy for that here. There's not one that immediately comes to mind, but
I've seen a video on. I've seen a video on YouTube that helped me just, I already knew that a Fresnel zone kind of looks like a stretched out long football or a cigar.
Yes, exactly. There you go.
There you go. And just because you can see the other antenna, you've got to have this clearance area, and the clearance area gets bigger, fattest in the middle, and then skinniest at the end. So it looks like a big stretched out long football or a cigar. But it's amazing how this area has to be clear. Otherwise, destructive interference can resulting in a lower signal level at the other end. And if I can find the link to the YouTube video, I'll include it in the show notes of this show so people can see this. But I saw one that that's why I always knew that you had to have a clear Fresnel zone, but I didn't always know why. So anyway, suffice to say that you do, and these calculation programs that you can see on the Ubiquiti website, what that Fresnel zone needs to look like and where it needs to be clear, right?
Mm-hmm. Yep. So
All right.
there's a really cool tool that we like to use called Ubiquiti Link Planner, and it's a free piece of
Okay.
software, and you can actually plan out point to point and point to multi point links with the software. So I can go point A on this tower to point B on this site, and make sure that they've got clear line of sight and a clear Fresnel zone. And it's cool because in the latest release of the software, it actually includes LiDAR data, which will show you any sort of foliage, trees, obstacles, anything, and it's fairly accurate. So even to get a baseline reading to make sure that you're going to have a clear line of sight or clear Fresnel zone between your two sites, it's a really cool tool to use, especially if you're using Ubiquiti devices. It's got all of the radios programmed in there. It's got all the Ubiquiti dishes programmed in there, but you can also throw in custom devices as well. So it's a really cool piece of software that's free to use, and it's called Ubiquiti Link Planner.
Link Plan, is that a standalone software or is that on their website?
It's on their website.
Okay. Yeah, I thought I'd used something on the website before, but it's been a while. Okay. Good to know. So you're saying that the radio's automatic selection of how fast it should go for the signal level and the conditions, it's ideal if that is sitting still and doesn't move around.
Correct.
If it's bumping, that means you've got changing conditions on your path, right?
Correct. Mm-hmm.
Okay. Let me ask you this. I noticed that some IP radios, I got some Air Fiber 5s, for example, they have a data port and a management port. Is it your typical practice to wire both of those?
So we really don't use the management ports on those radios. There are some people that choose to because they have completely separate management networks. Like if they're running a ton of devices on a tower, they may have everything in an out-of-band management system. We do everything in band just because we keep things simple. We don't over-engineer things. We keep things extremely simple, follow a lot of industry practices. So what we do is we only use the data port on those, but for our management, we have a management VLAN across the network that we tag on that interface so that it gets a specific IP address that is separate from the last mile subnet, as we call it. So for example, everything on our management network gets a 10.x whatever address. Anything that is outside of that, that's in what's called our last mile bridges, it gets a 100 dot address. So it's in a completely separate subnet from everything else, to where if a customer tries to plug directly into our network, they're not going to be able to see any of those devices because they are in their own VLAN. So that's just a security feature we use, but it also helps us to make sure that all of our managed devices are in one subnet and everything else on the network is in another, such as the routers that we provide customers, customer-owned equipment, etc., things like that.
Hey, in your wireless ISP business or model, if a customer says, I want a static public IP address on the internet, can you or do you supply them with that, or is that just not part of what you're set up to do?
Yeah, absolutely. We can for sure do that. So the way that we do it right now is a little bit complicated because we actually have a DIA from Windstream currently, and Windstream is kind of tight on their IP addresses. So their price is extremely steep when they start giving us IPs. Now, granted, we have started the process to get our own block of IPv4 address from the American Registry of Internet Numbers, which is the organization that actually hands out those IP addresses to the service providers and whatnot. But there's a pretty long waiting list right now, and we followed some other regulations to try and get them quicker. But it's still a bit of a waiting period to get those. So yes, we can give customers static IPs. I'm going to give a shout out to a company here because they have helped us greatly with this. There's a company called Core Transit that we have used for several businesses that require static IPs. We don't have enough to give to all of our customers and our business customers separately, because a lot of businesses want a static IP for whatever reason if they've got certain services that they're running that actually needs a routable static IP. So we use a company called Core Transit. It's ran by a couple of guys that are very active in the WISP community. They're very trustworthy. And basically, they hand us a configuration file that we put on a MikroTik router of our choosing. We configure that how it needs to be at the site location, and we can actually tunnel a public IPv4 address to a customer location from our internal network. So we just hand them just a regular internet connection, a CGNAT internet connection, like we would any of our other customers, and they actually now have full control over that publicly routable IPv4 address at their location. So that's the temporary way that we've got around this restriction of not having enough IPs for everyone. But that's going to soon change once we get our new upstream provider. We're migrating to a separate upstream provider that's going to give us an entire 24 block from them. And then once we actually get our own IPv4s, then we'll have full control over the entire thing of however, whatever we want to do with those, basically. But that's how we've got around that temporarily, just given that, we're restricted on how many IPs our current upstream provider to the outside world has allotted to us.
This sounds very smart. As soon as you started to explain what Core Transit does, I thought, I'll bet they have a public IP address and they tunnel that to the end user. And sure enough, wow, okay. Good guess, Kirk. I got a couple quick definite. You mentioned the term, your DIA is from Windstream. DIA stands for what?
Direct Internet Access. It can stand for direct internet access or dedicated internet access, but basically it's just a wide open pipe to the outside world that goes through another service provider.
Like Windstream. Yeah. Okay.
Yes. So a DIA is... Go ahead. I was going to say, DIA is different than any other sort of other service because it gives us resale rights on that service. So whereas if you just got like a normal Comcast circuit, even a business circuit or an enterprise circuit, there is strict no resale clauses in that does not allow you to resell that. It's against their terms of service. With the DIA, we can do whatever we want with it. Nobody's going to tell us different because that is our direct internet access to the outside world. It is treated completely separately from any sort of residential or business connection through that service provider, has guaranteed uptimes. We have an SLA with them. We have contract agreed terms and some other unique things that make it ideal for smaller companies like us that aren't a major provider to be able to have a direct pipe to the outside world, basically.
You also mentioned a term, I think you said CG9. What is that?
CGNAT, so carrier grade net.
CGNAT. Carrier grade NAT. Yes. Okay, sure.
So whereas typically network address translation is, hey, we've got a public IP. I'm just going to use like a regular example here. Let's say we've got a public IP coming into a customer router. You've got a whole bunch more devices behind that. So what NAT does is it basically says, hey, here's the public IP. It takes all the traffic of the end user devices and funnels them into the public IP, and the router is what hands out all the different ports and connections and whatnot to those other devices connected to it. CGNAT is a little bit different. It stands for carrier grade network address translation. So where we've got a pool of IP addresses, I think we've got either 13 or 15 IP addresses that we use for our CGNAT pool currently. And that's we're running real tight on it. So that's why we're trying to hurry up and get our new upstream provider because we've grown so fast. We can take multiple IP addresses and hand those out to all of our customers on the inside using normal network address translation. So instead of just using a single IP address to do their NAT, we're using a block of IP addresses. So that's what makes it a carrier grade network address translation compared to just a regular NAT solution.
Gotcha. Good. Hey, we're talking to Cam Lasley. He is the owner at Telecast. They do wireless ISP services in central Kentucky between Louisville and Bowling Green. And he's also a broadcast engineer. We haven't talked much about your broadcast engineering. We'll get into a little bit of that as the show continues. I'm Kirk Harnack, and This Week in Radio Tech is brought to you in part by my friends at Broadcasters General Store. BGS.cc is their website. And I know I've sung the praises of this product before, and I will keep doing so because it really works well and it solves a problem. And that is from Henry Engineering, the back UPS. The back UPS is a power controller for ensuring reliable AC power to critical equipment that's powered with a UPS. So back UPS constantly monitors the output of the UPS and automatically bypasses the UPS if its output fails or becomes unstable. So the back UPS has two AC inputs, a line input and a UPS input, and the line is plugged, of course, directly into a local AC socket. I call that commercial power or shore power, and the UPS input is connected to the output of the UPS. Now, at some of my radio stations, I've got a rack full of gear that has two power supplies each. These are typically servers and some broadcast gear, and that's easy to handle. You plug one power supply into the shore power and the other power supply into a power strip that comes from your UPS, and that's all great. So if the UPS fails, which they always will, then you still have shore power. Well, I got a bunch of equipment, and so do you, that doesn't have two power supplies. It only has one power supply. And, if your UPS fails, you need that gear to keep on working. And if you need to change the batteries on the UPS or do some battery testing, whatever you need to do on the UPS, more often than not, it's going to cut the power off. And you don't need that. You don't need a 5-minute reboot on an Ethernet switch that only has one power supply. So this is where the back UPS comes in. It will instantaneously move that equipment over to shore power while you work on the UPS or while your UPS decides to fail. Either way, the back UPS is a great solution for this. We just put 4 of these in our new station cluster on Maui, one for each rack. And I've got also one of these at the stations in Oxford, Mississippi, where rack full of gear that most of it only has one power supply, and this keeps everything alive. Back UPS is a great invention from Hank Landsberg at Henry Engineering, and you can get yours from Broadcasters General Store. Their website is bgs.cc, but you know what? If you want to pick up the phone and give them a call, they love it. They do great phone at 352-622-7700. 352-622-7700 for Broadcasters General Store. And of course, they have a lot more than just the back UPS. Anything you need, including if you're putting some television equipment into one of your studios, they can help you out with lighting and cameras, proper microphones, even mic arms that stay out of the camera's way, all kinds of stuff like that from Broadcasters General Store. Thanks, BGS, for sponsoring This Week in Radio Tech. All right, let's see. I had a question that we didn't get asked in the last segment, Cam, and that is about how much bandwidth do you guys budget to have? In other words, how many thigh masters do you put in your gymnasium, considering the number of gym members or considering the number of customers you're going to have? What's the math on that, providing people with bandwidth that they're happy with?
Sure. So a typical rule of thumb when it comes to the WISP industry, and this is probably gonna shock a lot of people, but I have 5 years of evidence to prove this. The average customer utilization, if we look at all of our customers across our entire service area and look at their average utilization during their peak hours, not just overall peak hours, during that customer's peak hour of usage on average, it's less than 7 meg on average during peak hours. So sure, you're going to have some outliers that are downloading video games or that are streaming on a ton of devices. Currently, we've got a 2 gigabit circuit that feeds our LaRue County network. So that's our largest of the network. We've got 15 or 16 towers that are connected onto that circuit, that DIA that we've got currently. And so just for perspective, right now we offer 30, 50, and 100 meg packages on our AirMax stuff, and we offer 250 and 500 on Wave. During peak hours, we've got around 350 customers on our LaRue County network. We are just under 2 gigs of throughput. So if you do the math, I'm just going to use 2,000 just for an even number here and divide that by 350. That's about an average of 5.7 megs per user. And, I'm on my own network here at the house. I'm connected to a grain elevator that is just down the road here with a point-to-point link. And then there's another point-to-point between that grain elevator and our tower. And even during peak hours, I can sit in my house and run almost 100 meg speed test during peak hours, which I consider fantastic because we only have a couple of customers that have higher than a 100 meg package, and they're on our Wave service using that 60 gigahertz equipment. So, you know, really there's not as much throughput as what most people think. So whenever somebody tells me, oh yeah, I need a 5 gig fiber circuit from my rural co-op ISP, I just kind of my eyes roll so far in the back of my head it hurts. Because I'm like, what do you need that amount of bandwidth for? Like, I'm an entire ISP here and I've got 2 gigs on one of my networks, and granted we've got a couple other circuits for some of our smaller networks, but I'm just like, what do you need that much capacity for? That's just insane. And it drives me crazy how many service providers, Windstream especially, they've got a giant banner on one of their IX buildings here in Hodgenville, right in downtown Hodgenville, that says largest 8 gig service provider. Who is going to use that? There is no logical need for an 8 gigabit circuit. Is it really fun to take a speed test and watch the needle go? Yes, it's awesome seeing that fun. Needle just pin itself over. But at the same time, it's so completely impractical. I've had numerous stories of where we've gone and, talked to somebody, hey, you should give us a try. Like if I see them upset about like their service provider, something like an outage or whatever, I'm like, hey, you should give us a try. And they're like, okay, well, what speeds do you offer? And I'm like, well, for most of our areas, we offer up to 100 meg. And they're like, oh, that's way too slow. I've got gig now. And granted, if they've got Comcast gig, they're capped at like 40 up. So, okay. I've had numerous cases where I've been like, give us a shot. I'll give you a free month of service. I won't even charge you for installation. Give us a try and see how this works for you. And they always come back and they're like, yeah, it works great. Gaming doesn't lag out. We don't have all these buffering issues in the house anymore. And I'm going to touch base on something else regarding that a little bit later. But, it kind of blows people away that these larger service providers have led them to believe that they need 250, 500, a gig worth of internet service, when in reality, the average household uses less than 30. 65% of our customer, of almost 600 customers, use or are subscribed to our most basic 30 meg down by 10 meg package, and a lot of them don't even use that. It's enough to do plenty of streaming. The kids can game on it and whatnot. We don't have a ton of latency issues on the network like some other WISPs have experienced in the past, or what people think WISPs deal with. They're like, oh, WISPs are awful for gaming. Not always the case. We engineer our networks very, very, very well. So, being able to educate customers that, hey, you only need a fraction of what you've been led to believe is always such a rewarding thing. Seeing that they're always much happier with the service too, because anytime they need something from us, we're local. I'm a phone call, a text, or an email away, and they know that I'm going to take care of them, and I'm not going to be like Comcast, where sometimes you can't even understand the people that you're talking to. We're a small community here. We're a small rural community, and people like supporting small local businesses, and they also like staying local. They want to deal with people who are local to the area, know the area, and it gives that personal touch to things. But yeah, I always really shock people when I tell them, how little our network actually uses, and nobody has any issues.
Yeah. I guess you want to look good on a speed test because that's what people think that they have and they want. But in actual practice, they're not using this. I will tell you, and here, even at the Harnack House, at my office, I don't use a whole lot of bandwidth up and down. We may be watching 2 Netflix at the same time, but usually not. The one thing I like high uploads is when I'm uploading a big video file for my employer, Telos Alliance, and that sucker uploads in 12 seconds and it's done. I'm not waiting an hour and a half for a big honking file to upload. So that's nice to have. But you're right. It's a bit like I got a muscle car. It'll do 186 miles an hour. Yeah, but if you put a computer on and see what your average speed is, it's 28 miles an hour around town.
Yep,
right?
Exactly.
Hey, Cam, I can tell you right now that we're going to need to have you back on the show at a future date because we're going to be out of time here in the next 10 minutes or so. You mentioned, and I didn't write down what it was. You mentioned that you wanted to mention something else. You said later in the show. I guess now's later in the show is something that you just mentioned in the last couple of 3 minutes or so. Remember what it was?
Sure. So I want to talk about something that us as service providers call the last foot. So when it comes to broadband infrastructure, you've got your middle mile infrastructure, which is the long haul that is usually fiber point-to-point links, where fiber comes into an area or connects all of the data centers and whatnot across the United States. That's what we call our middle mile infrastructure. The last mile infrastructure is from those demarcations or hubs, as some DSL or coax or fiber providers call it, to the person's home. That's the last mile delivery. What I'm going to touch base on real quick is what I call the last foot. And my one of my friends up in Nicholasville, John Gill, touches base on this really, really well. A lot of customers don't really know exactly how to properly set up their Wi-Fi at home or make sure that it's optimized. There has been numerous times where we've seen these super high-end routers that people want to go out and buy, like these Asus or TP-Link gaming routers or whatever, that think it's the biggest and baddest thing, and either it's not set up correctly or it's not optimized properly. They could have Wi-Fi extenders in the house, like cheap little Chinese Wi-Fi extenders that bring the whole network down, or other variables such as low signal levels as part of the house. I've seen numerous cases where service providers have installed the modem in one corner of the house, and they're trying to connect devices in the opposite side of the house, and the Wi-Fi signal is really poor. So when, especially us as smaller companies, we look at the last foot pretty extensively as well. So one of the cool things that we do is we offer a managed Wi-Fi service. It's included for all of our customers. There's a lot of ISPs that charge on a monthly basis to have a managed Wi-Fi solution that's supposed to take care of all your issues or whatnot. But we can see and we'll get logs if we notice that a device is performing poorly. So for example, if we notice that a lot of devices connected on the home Wi-Fi have really bad signal level, and the customer calls and says, hey, we're struggling with this buffering, or hey, our security cameras aren't working right, whatever the issue might be, we can look and see, okay, what's the connection quality from the router to those devices? Because if your device does not have a good connection to the router, everything else past that you're trying to do on that device is going to be awful. So what we do whenever we do installations is we look and see, okay, where's the optimal place to put the router here? What is the layout of the house? Where's the internet going to be most used at? And we typically try to do a central point to it. But we also install mesh devices. So if, let's say a customer has a larger house and they need more Wi-Fi coverage, well, we just set one up wherever it needs to go in the house, and we can set up another one to make sure that the Wi-Fi strength going to all of the devices in the house is plentiful. Because, like I said, if the device itself has a bad connection to the router, then that customer experience is going to be awful. So that's one of the unique things that we do when we install. We make sure that pretty much everywhere in the house that the internet connection is needed has a good connection quality back to the router. That is arguably one of the most important things on the customer side of things. So that's what we call the last foot.
Gotcha. Makes good sense, and certainly that's where a lot of things go wrong. It's that the last foot from the router to the customer's equipment. And we got to take a break, but if you have a Wi-Fi hotspot in your home, and I've gone through a bunch of them here at my house that either just quit working after time or whatever. So I've ended up buying some kind of commercial grade units, and they've lasted a lot longer. But how do you decide, hey, do I turn on both 2.4 and 5 gig networks on this Wi-Fi hotspot or on my router, if that's where it's coming from? And which one do I use? Now, some devices, I got a bunch of Wise cams around the house here. They only work at 2.4 gig, so you don't have a choice there. But how do you decide which you want to use?
So typically, if we are installing service for a customer, and let's say it's a smaller house, most everything is going to connect to 5 gigahertz. So we use the TP-Link CGNAT series of routers. It's their ISP grade routers that has full remote manageability to where we can see insights as far as connected devices and whatnot. That helps us to suit that last foot connection quality. So typically, we set what's called Smart Connect, and that allows the router to automatically decide what devices need to connect to 2.4 and what needs to connect to 5 gigahertz. And for 99% of devices, that works fine. And it works really well in that. It'll go to whichever one has the best connection quality, typically based on the device being connected. Now, what you said about the Wise cameras, that's a great point, because there's a lot of IoT devices out there that still utilize the 2.4 network. And the reason for that is, especially for devices like cameras, typically they're going to prioritize range, since they're going to be mounted outside of the house under most circumstances. Most people just have cameras on the outside of their house. So the 2.4 band will reach further, but it's not as fast as the 5 gigahertz network, which for security cameras is fine because they might only use a couple of megs. However, pretty much anything else that is within semi-close proximity of the router is probably going to use 5 gigahertz because there's less noise, it's more stable, and it offers a better connection quality with faster speeds than 2.4. So that's just kind of a typical overview there. So most devices nowadays use 5 gigahertz, but there are some IoT devices that still use 2.4 just because 2.4 does reach further than 5 gigahertz.
Yeah. Okay. All right. We're talking to Cam Lasley. He is a Wi-Fi expert, and that puts him in good stead here with point-to-point links for that broadcasters use. And, our hour is almost totally gone right now. We got to have Cam back to talk more about the intersection of IP radios and IP devices as it relates directly to broadcast, because Cam also does broadcast engineering, and we got to get more advice on that. So we've spent the last hour on lots of Wi-Fi and point-to-point IP radio topics. If Cam is agreeable, we're going to have him back at some future date. Hey, our show is brought to you in part by Angry Audio. Don't get mad, get angry with Angry Audio and their Rave console. I see more and more pictures of the Rave console now. Catfish. That is Mike Dosh, the owner of he posts these on Facebook when people install a Rave radio mixer. Love these little consoles. This is an analog console. Nothing digital here. Well, except buttons that go on and off, but the audio is all analog. But you know what? Mike Dosh is a real expert at analog circuit design. That's how he got started. He designed all kinds of things like guitar pedals and things like that when he was younger, and then he worked at PR&E designing audio consoles at Pacific Recorders and Engineering, and now and he was my boss for a few years at Telos Alliance, but now he has his own company, Angry Audio. This Rave console is simply superlative in terms of an analog audio console. Easy to connect and wire up. It uses Studio Hub audio connectors for your in and out. So that means it's really quick and easy to wire up. It does have XLR connectors for your microphone input. So it's got 4 mic inputs, and actually mic or line inputs on the first 4 faders. It has 2 different mix minus controls. Of course, it's got, the control room monitor output and the headphone output and the studio monitor output. The Rave has 8 faders. And then the 2 extra faders there over on the right-hand side are for controlling the monitor volume and the headphone volume. You can get the Rave console from your favorite broadcast equipment dealer, and you can check it out at the website at angryaudio.com. Love this console. You're going to like it too. It is perfect, and it's very, very well built. Our show is also brought to you in part by Max Connect, and I got to remind you about this amazing product. There's nothing else like it on the planet. There really isn't. If you want to run an FM audio processor on a PC platform. There's several of them on the market that run in Windows. You can make it very reliable. You can stop Windows from doing updates, for example, so you won't be taken off the air. I've got a number of these running myself. Omnia SST. There's also Stereo Tool, and there's Breakaway One. You can put this audio processing software on a small computer, but then you got to get the audio in and out, and you got to do it really well, especially the out. If you need the multiplex output, right, that's the composite baseband signal. There literally is nothing else on the market that's designed to do that. There's a couple of sound cards that purportedly do this, but you got to fiddle with their drivers, and they may or may not work as well as composite signal is let's call it a fragile and persnickety signal. It needs to be exactly right, or your FM stereo isn't going to be right. Well, the Max Connect U.192 box is designed specifically to give you a composite output from your PC-based FM audio processor like Stereo Tool or Omnia SST. Or in any of those. And it also, besides giving you the exact proper composite output, it can also give you analog and digital inputs and outputs for your stereo audio. So it does all that in one box. It uses a compliant USB connection to your computer, so you don't need drivers in your Windows computer to talk to the U192 MPX USB sound card. There's the back panel right there on the screen that Suncast is showing you right now. There's the USB connection, and there are the two B and C connectors are your composite outputs, and then it's got analog in and analog out, composite in and digital AES EBU in and out. Built-in power supply. This thing works great. It is absolutely the cat's meow. It's the top of the line, and it's the only thing on the planet that does what it does. So if you want to run an FM processor on a computer, I'm doing this at several stations, the U192. And if it's for feeding your transmitter, maybe locally there, wherever your processing is, or your composite STL, whether the STL is at its basis analog or digital, if it's got a composite input and a composite output, this is the right box to get for that as well. Check it out. Thanks a lot, Max Connect at maxconnect.com. Yes, it's spelled funny. We have a link in the show notes. I'm Kirk Harnack. We're about to wrap things up with Cam Lasley. Cam, once again, your host has done a complete failure in warning you that I need a tip of the week. So maybe in the next 12 seconds, you can come up with a tip of the week. What should broadcast engineers keep most at the forefront of their mind when they're dealing with Wi-Fi or IP radio issues? What's your best tip?
Don't do firmware updates on Fridays at 4 p.m.
Oh, yes. That's exactly right.
Speaking from experience, whether it's an IP link, whether it's, you're updating a software on a transmitter, I've had scenarios where I thought a firmware update was going to be really short and simple, Nautil, and we end up doing a software update, and then I'm there until like 8 o'clock trying to roll back the firmware and trying to fix the mess that I made and taking down stuff. It's happened. It technically wasn't my fault because there was the instructions were incorrect that I was given. But anyways, don't do firmware updates late in the day on Friday. Wait until Monday morning, or wait until Sunday at 7 p.m. when everybody's not listening on air or relying on whatever you're about to update or potentially break.
You're so right. And this is the conundrum with firmware updates. You want to do them when nobody's listening, or, midnight on Sunday night, Monday morning, right? But guess what? Support probably isn't at their desk at that time.
Exactly.
So, yeah, we at our stations, whether it's a router update, a Ethernet switch update, or playout software update, we try to do those on a weekday, but we got to make other arrangements for something to play on the air while we're doing the update, because it might be 4 minutes and it might be 4 hours.
Mm-hmm.
So, Cam, I've enjoyed this terrifically. I'm sorry we didn't get to any pictures yet, and this is another reason why we need to have you back on the show. We just filled the show with great information, and I'm so glad to have you. I'll put you on the spot. Can we get you back sometime this summer?
Sure, absolutely. And I would have had some pictures ready for you. I literally have a Gmail window open where I was about to send you the Google Photos link. And for whatever reason, I didn't click send. I think I got sidetracked getting a couple things set up here on the table and forgot to click send. But we'll touch base on that next time we meet, whenever that might be. And I can show some real world pictures of what some of our deployments look like and some of the other things that we dabble with as far as integrating the wireless technology side of things with actual broadcast work.
I'd love to hear about that and see the pictures. And hey, today we filled the time without even thinking about having time for pictures. So I appreciate, what a brain dump. I'm going to have to go back and listen to this episode again to make sure I got everything. So, Cam Lasley, thank you so very much. We'll also have your contact, your company's website in our show notes today. Cam Lasley's been our guest. Thanks very much. Good luck to Chris Tarr, wherever he is. I know he was traveling and doing some transmitter side work. And a big shout out and big thanks to Suncast, our producer up in the Detroit area. Suncast, thanks very much for producing another show and doing a great job of it. We appreciate you very much. And hey, if you're a listener of this show, as we do have hundreds or thousands. Actually, we do get thousands of downloads. Be sure on our YouTube channel to hit the subscribe button and hit the little bell for notifications. We'd appreciate if you got notified. If you watch us on Facebook, that's great too. And love to hear from you. You can always write to me at thisweekinradiotech@gmail.com. I do get those. thisweekinradiotech@gmail.com. And we'll see you next week on This Week in Radio Tech. Bye-bye.